temática número 5, teorias da música popular. Good morning, everyone. It's a special satisfaction and honor for me to have been invited to mediate this table, considering both my career as a musician and academic researcher. Thematic studies in popular music form new but very attractive and promising lines of research, an area that has only recently aroused interest in postgraduate music programs in Brazil and other countries, but with very strong intensity, which can be observed in the increasing number of articles, dissertations, theses, especially involving the exuberant diversity of popular Brazilian music. Studies on the structure of musical genres such as short, samba, rock, blues, etc., and the creative process of composers based on the application of analytical methodologies originally devoted to the scope of concept music, see a growing formulation of new theoretical proposals and analytical models involving Gabriel. Study on the structure of musical genres such as short, samba, rock, blues, etc., and the creative process of composers based on application of analytical methodologies originally devoted to the scope of concert music, see a growing formulation of new theoretical proposals and analytical models involving issues such as metric and rhythm, harmony, thematic treatment, instrumentation, especially for the peculiarities of popular music. I'm sure that today you had on this table an excellent sample of this current picture, so intellectually stimulating in its diversity. I now present our distinguished guests. First, Dr. Gabriel Pareyon, composer and musicologist, PhD, University of Helsinki, with a dissertation about similarity in music, both semiotic and mathematical approaches. Master in composition and music theory from the Royal Conservatoire, The Hague, Netherlands. Currently, he teaches at the Pós-Graduação program Faculty of Music, UNAM, Mexico. Since 1995, he is the tenured researcher at the National Center of Music Research, Documentation and Information, CND, Mexico City. He organized the first International Congress on Music and Mathematics, 2014. He is editor of the book, The Musical Mathematical Mind, published by Springer International. Both we have the honor and the great pleasure to participate. Me and I am Pauschi. Thank you for this. Please let.
Muito obrigado, professor Carlos Almada, professores Pauschi, Gabriel, Gabriel também, muito obrigado pelo convite. So I'm trying to speak about my main interests, theoretical ones and practical applications, and to I won't say popular music, but I want to provoke and invite you to discuss some ideas about non-linearity. First of all, I will give some key clues on this. But before would say that my first approach to the history of popular music in Mexico was a quite lexical approach. The design of the first encyclopedic work about Mexican music, mostly popular one. This is almost 1,200 pages encyclopedia of Mexican music, published first edition in 1995, and you may download this from the internet if you are curious about a general approach, but a lexical approach to Mexican music. I'm talking about this because in the 90s I was very obsessed with classifying concepts on Mexican music. Mexico, as probably you know, is a kind of collection of different cultures, contradictory social and historical constructions. So a dictionary, an encyclopedic dictionary in this was never attempted by any musicologist, but as I come from the province in Mexico, Mexico is a quite centralized country. I was very naive trying to gather all this information to put some light to all these issues. But with the years, I just discovered that a lexicography collection on these issues was not really enlightening the big issues. So after documenting different kind of aspects on the subject, I start to worry about the deep meaning of musical practices. And since I love mathematics, although I am a composer and musician, I love mathematics in order to improve some musicological tools. And in the last 15 years, I devoted special attention to applying non-linear models to understanding dynamics of musical practices. We have in musicological modern literature lots of graphs just like this, like scattering patterns, scattering plots. But I would summarize the meaning of non-linear or non-linearity in terms of the difference between the summation of elements in linear definitions as a basic way for understanding complexity, linear complexity, and by difference of another kind of systems where the summation of the elements in a function is not meaningful or not possible. So it's a simple formalization in mathematics. The function of x plus y, which is linear, is not necessarily equal to the function of x plus the function of y. So we have dynamic behaviors, and it's impossible to describe them as just a consecutive behavior like may happen in a dictionary. So why should pay attention for this? Well, from the ambitious project of ambitious project of classifying music in a lexical order, I just jump into a much more simple way to speak and to think about music. For instance, analyzing just one instrument. And one of the most ancient and interesting instruments in Mesoamerican musical tradition is the TeMA. And this is rather a simple instrument. It's just a wooden carbon log instrument with two pitches. And this is lick drum, and we have an incision in this log. And this instrument was designed about among the 11th and 14th century in Mexico. It's quite probable that before that the original instrument was a turtle, I forgot the name, the turtle hard structure.
Correct.
Yeah.
Correct.
Yes, the skeleton. So we have two pictures as well from a female turtle of a certain species, and we have this instrument depicted in the Bonampak mural from the 7th century, accompanied by other instruments in the Mayan classical orchestra. So, first of all, I try to depict the behavior of this instrument because of its apparent simplicity. Nevertheless, this instrument was used for studying, during many centuries, for studying the Mesoamerican traditional metrical food organization for music and poetry. Although in Mexican ancient culture, there is no very clear division between poetry and music. Musical culture before European countries was rather quite compact and synthetic, not analytical and separating everything like the European tradition. So in this book, Musical Mathematical Mind, Dr. Silvia Pina is here, and we published the physical study of this instrument, and we discovered that the instrument is able. Sorry, Bashi, can we turn off the air, please? I think it's too noisy. And we published a physical description of this one-piece lock instrument, and we realized that we have interesting dynamics where, although we have only two slits, when we hit one of these slits, we have the resonance of the other in an interesting proportion. Thank you. All publication, studies published in along the 20th century about this instrument told us that it was a very simple instrument, and there was nothing to learn from this. Because the focus of musicologists in the 20th century was attempting to describe this instrument in terms of Western tradition. Nevertheless, paying more attention to the physical behavior of this, we discovered that this complementary behavior of the slits, making part of the same instrument, which is in itself its own resonance box, we realized that we have a kind of synchronicity behavior, which is not possible to describe in terms of linear terms, but in a dynamic way. And second, in a second explanation, I should say that the instrument was not played. It was not so usual to play this instrument, the timpanously, in an isolated manner, but in orchestra. So after almost 500 years from the Spanish conquest, we built the first modern ensemble of timpanously, and we started to discover very complex behavior of not, I wouldn't say pitch or pitch class kind of structure, but complex dynamics of textural interesting structures. If you are interested to look at these performances, you may look for this in this Vimeo address, just in case you want to see it and appreciate the complexity of this sonority. I took a text from the 14th century, which survived to the destruction of all ancient books. It's a theatrical kind of piece, and we gather information from the 16th century in order to reconstruct this popular music from pre-colonial times. And then this piece was prized in the opera Musicological in Rotterdam, and we won some prizes in different parts of the world. And finally, we start to recover little by little these interesting sonorities. We designed a catalog of a collection of these instruments, which are replicas from the original ones. And what theoretically I find much more interesting using these instruments is applying in a comprehensive model the behavior, simple and complex behavior of this instrument. As I said before, we have two slates in this slate one. But what happens if we couple theoretically all these instruments, which are not tuned in a fixed system, but we have big instruments, small instruments, and very small instruments. How can we map? How can we build a comprehensive model for understanding the behavior, non-linear behavior of these instruments? So this is my idea. This is not, at least we don't see this theoretic model in ancient times or ancient books. So this is my proposal for solving the generalization of this instrument behavior. And I couple the big instrument with smaller instruments, and then two smaller ones, and so on. And we have, by the way, these lines are necessarily not straight lines, not curved, but not straight ones, following the original designs for these instruments, because we don't have any teponastly equal to another one, and this is quite important for Mesoamerican philosophy and sonorities, apparently. So I call this the forest of teponastlis. That's the meaning of that word. Teponatzcuautla. Cuautla in Nahuatl language means forest, and teponastli, is the name of this instrument. So indeed, this is a non-linear model for an extended comprehension of this complex sonorities. We may program this in the computer and explore different kind of solutions, and we even can specify the starting point for exploring this complexity. For example, defining the length of these first two slits, and then abstracting the sonorities from this first step. So, of course, this is a fractal object, and it has interesting mathematical properties. We can extend this model even to the extremely complex world of aerophones we have in Mesoamerica and in Mesoamerican traditions. String instruments were not very important. In many senses, we say that Mesoamerican philosophy and music and culture is like the opposite, like a symmetrical opposition regarding Europe, because the European tradition and Indo-European tradition pays a lot of attention regarding to string instruments and voices, sometimes voices playing together or imitating the strings behavior. But instead of that, we have in the first place the percussive world, composed by a very important duality of two main percussion instruments, the teponastli and a membrane drum, the huehuetl. Huehuetl and teponastli compose the first duality. So it's a kind, since the beginning we have a duality of dualities, but never like a mirror, like radial symmetry, but an imperfection, not perfect symmetry, and this is the key concept for this conceptualization. Well, Teponatzcuautla seems to be, for my theoretical developments, a quite useful approach characterizing popular music dynamics because of its kind of non-linear but as well non-symmetrical behavior. And of course, I'm trying to get back my steps from Mexican context to a more generalized ones, because we have scattering patterns everywhere in music. This is a definition of lexical definition of Mexican music from my former encyclopedia of music in Mexico, where we define, we have certainty the more we get to the center, but precise definition of this object or this universe is not possible, but just like a cloud approach. We can apply this for style analysis in music, even in classical or other kind of genres of Western or non-Western music. We can apply this scattering pattern as well to a probabilistic approach for performing in a specific tuning system. And these are commonplaces actually in systematic musicology. What is quite interesting to me is how traditional and popular music are guided all the time by kind of cloud nucleus or cloud attractor. This is Frans Grovenhoven, a Dutch musicologist from 2005 paper, representing 5 versions of the same Chinese popular song. We appreciate small differences among them, and this is rather quite obvious in popular music. And what I find quite interesting is applying this concept of attractors for a recursive system, like in generative linguistics. Yesterday and 2 days ago, we listened to some quotations from Lerdahl and Jakobov's book on generative structures of tonal music, inspired first of all by the doctoral thesis of Noam Chomsky's on generative grammar. And it's quite interesting that these models are coming from linguistics. But as we know from information theory, human languages, natural languages as we call them, they function in a thermodynamical context. So languages behave in a rather specific way regarding thermodynamical principles. And what is much more interesting to me is that in a almost pure mathematical context, numbers behave as well in this, following this pattern, in a kind of a scattering plot where prime numbers lead the kernel of rhythmic behavior, the so-called Z-Riemann function, not Hugo Riemann, but the mathematician one. And this is an obvious function describing quite an almost perfect linear behavior of natural numbers, but scattering the patterns of prime numbers. If we map the behavior of the first quotients, the first 12 quotients of prime numbers, for instance, dividing the first prime numbers are 2, 3, 5, 7, 11, 13, and so on. If we divide 3 by 2, 5 by 3, 7 by 5, 11 by 7, and so on, we construct the diatonic scale approach, and the more we get away from 13, 23, we lost the semitone. We saw several, at least a couple of examples yesterday and 2 days ago about the lack of this semitone. I wonder whether this is a property of this natural number skeleton, or natural structure of the physical world, or I don't know. But what is quite interesting is how these patterns are not exclusive to music, but they are following a generalized pattern in thermodynamics with a very interesting correspondence in pure mathematics. By the way, the previous scattering plot is from this equation, which is rather popular and commonplace in modern mathematics, not complex one. And we have, for non-mathematicians, we have very rather simple tools for approaching both prime numbers complexity and the complexity arising from natural numbers, like in the Pascal triangle, which is quite useful for analyzing harmonic and rhythmic patterns using natural numbers. We have ones like everybody knows when approaching this triangle. We have the number 1 here. In the second row, we have natural numbers 2, 3, 4, 5, and so on. And then we start to build some numbers, which every single number here is resulting from the sum of the previous ones. Like 4 is the sum of 3 plus 1, and so on. But an interesting arrangement in this Pascal's triangle is that we start to get some interesting patterns like Fibonacci series with these diagonal lines. And I just wonder that in this brown hexagons we have natural numbers which are most popular in popular musical meter, and the purple hexagons are the most important, the most classical ratios composing metrics for the Teponasli. I almost would say that in Indian ragas and talos we may map in the Pascal triangle these numbers because it's a kind of intuitive approach to this complexity, nevertheless in a very compact space, which is in a certain way intuitive. But the most the more deep we are in this distance, in this depth of the Pascal triangle, we start to find more interesting patterns. As far as I know, the first musicologist who was reflecting about this complexity and applying this for musical composition and musicology was Mexican theorist Erwin Wilson, who died. Those years are wrong. He was born in 1928, but he passed away 2 years ago. And Erwin Wilson developed several interesting tessellations for understanding tonal music and microtonal complexity, starting by the Pascal triangle and other mathematical objects that at the beginning are quite simple, but their developments are rather complex. We may employ these complexities to build like this more complex objects. This is the same, the Pascal triangle, but we start to, as I said before, we may start to discover some inner patterns like this Sierpinski triangle, and we may apply this complex dynamics to build nice objects like artificial bubble. And by the way, bubbles present dynamics quite similar to music complexity. When I felt this approach to non-linearity in bubbles, I bought this beautiful, full of differential equations book, The Acoustic Bubble, and I realized that I didn't need some extremely complex mathematics to understand what was behind this. So my own approach to musical complexity is like in a dynamic way, and in this year I was composing music for a bubble complexity just done by using salt and water and exploring the harmonicity obtained from this self-organization, from hierarchical organization, like big bubbles, small bubbles, and proportions between them. So my idea is, my general idea, and now I'm approaching to my conclusions, is that indeed we should pay attention to that trade-off relationship between complexity and digestibility. As a principle, I call this the principle of musicological acceptability. We have very heavy mathematical devices for understanding, describing, analyzing music, but sometimes so simple objects like the Pascal's triangle are enough to capture main interest or theoretical interest for analyzing and describing music. I just would like to finish my talk saying that if we, as Gabriel say, mathematicians, want to formalize popular musicalities, if something like that is possible, I would say that we should look for locally defined analogies. And the meaning of this is that we should define local properties by coherence with generalized properties in a whole system, and not attempting to generalize this to another kind of system. So probably we find elegant answers to big, mysterious questions defining popular music. It's quite important to realize as well that non-linearity in music emerges from musical practice. I would say that it's extremely important for musicologists to pay attention to thermodynamical principles, because the most important harmony book and metrical metrical book I know is thermodynamics and human intuition for this. And this is quite relevant for information theory. And I believe Chomsky and North American linguistic school paid attention to this, and this is quite important, quite relevant, and that's why Untitled is so often quoted. And of course we have fuzzy set borders, random dynamics, and social feedback. And this is also quite important because sometimes we pay too much attention to static formalization, rather to understand that musical phenomena is the dynamic one. And I will be happy to hear about your ideas on this in a pathway that I believe is leading us to a new stage for understanding musicalities. I will say that we have music as the first day of this Congress. I heard Professor Robin Moore saying that it's much more important to say, not to pay too much attention to our pretentious universalisms, but to these rather physical principles which are settling the complex kind of relationships where we are unable to formalize and generalize, but just a tiny part of this complexity. So that was
Now, we invited Professor Cliff Barr. Is a pianist, composer, and researcher. He holds a doctorate from Almada School of Music and master's degree from City College of New York. He studied in his hometown of New York with jazz masters Robert Hanna, Barry Reyes, Rob Carter, Kenny Burrow, and David Liebman. He's an assistant professor at Untitled, where he teaches subjects in the areas of studies in popular music and improvisation. He's coordinator of the Improvisa Research Group and the research project Elaboration and Knowledge of the Almada Archives. Other focuses of interest included Brazilian popular piano, history and practice, pedagogy and students of popular music, and the global circulation of jazz. He's coordinator of the graduate program Musicological and member of the professional master's program at the Untitled and PPG program of Pós-Graduação in Minas Gerais Federal University. Published articles included Pushing at Boundaries, the path of a Brazilian instrumentalist, and Almada's Epithet and Quartet, Summer Jazz as Musicological, popular instrumental improvised music. Please welcome.
Thank you. So, bom dia, buenos dias, and good morning. Let's see, I'm going to jump between a couple of programs here and also a couple of, okay, here we are. Keynote. This is, oh yeah? Oh, okay. Well, it's really an honor to be here in a place where I'm feeling extremely linear. And I hope that my look into one of the pieces of the American songbook, which has become a field of play, so it's something of a playground, I like to call it, for improvisation through the many eras and moments, phases of particularly improvised popular music, which frequently is considered jazz. I hesitate to use that word for other reasons, but it's an improvised popular music that has it's a large tradition that's informed by many lines of thought. So jazz is a short way of saying that. It's a symbol, I guess. So I'm looking into this song called All the Things You Are. And it's a puzzle piece for jazz improvisers. Since it came out, which is in a show from the end of the 1930s, since that moment through the 40s, 50s, and until today, it's one of these challenge pieces that's considered, in the jazz world, it's a challenge piece. If you show what you have on a song like this, because it's complex in its way. It's got pathways that, if you're not careful in practice and you're using rhythmic and melodic, let's call them cliches, you might slam into a wall. And so it's one of those pieces. I also use the analogy frequently with students of, when you're skiing, I know we're in Brazil, but when there's downhill skiing, and there's downhill skiing with no obstacles, and then there is downhill skiing with these turns that you have to make. Well, All the Things You Are is one of those that you have to have skill and you have to know how to continue the momentum of your playing, but you also have to know what's coming and how you're about to get around it. Otherwise, you fall and you lose points, and etc. So I call this little research project "All the Things You Are and Could Be," would be in English. I sometimes use "and could have been," but I think "and could be" is better, the present tense. And I look into the way that we might prepare to hit those curves, and to take those curves, I guess would be the best way to say it. So let's see if I can know how to do this. How do we do that?
I press play.
Play.
Just play?
Yes.
Just play and it'll go without me? No, I don't want to. No. Okay, so maybe that, okay, yeah, that'll do it. Great, got it. So, All the Things You Are is written by Jerome Kern, the music and the lyrics by Oscar Hammerstein, and it was in a show, 1939. Nobody really remembers the name of the show anymore, but there it is. It was a disaster of a show. It closed very quickly. But Jerome Kern was the writer, and after this, historically, he ended up writing more for film than for Broadway. But it's one of these songs that's generated by shows. And very quickly, it's taken up by popular musicians. It's been sung by Ella Fitzgerald, Frank Sinatra, Sarah Vaughan, Barbra Streisand, etc. through the years. Again, it's a standard popular song, and it's also a standard popular, as I call it, playground for instrumental music, which included Charlie Parker, Dizzy Gillespie, Miles Davis, Wes Montgomery, Coleman Hawkins, Sonny Rollins, etc., 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 until today. So, here's the song. And this is the type of symbolism that a popular jazz musician will face, or a popular improvising musician, if they don't already know the song. This is just the presentation of the song. And I'm going to say something obvious here, but it's pertinent. Because this type of what's in Portuguese called melodia cifrada, a lead sheet, contains a very minimum of information as far as how this is to be realized. If we want to look at it just to say, okay, it starts on F minor and then it moves through a number of chords called chord changes, which symbolizes some vertical positioning, a vertical entity, which moves in a progression as chords begin to have relationships with each other. And then that melody here, oh, thanks. This melody here is played together in this harmonic moment. Okay, well, we see that that's true, but I would bet, and I haven't done the research, but I imagine it was never played like this. Because rhythmically it's informed, it's not informed. There's no style here, there's no genre, there's no individual style, there's no group style, there's absolutely no rhythmic information here. There is, even in the popular song world, it's very rare, in fact, so rare that I don't know that I've heard one, where every moment is on the downbeat. It just wouldn't be played like this. So my question is, what I question when I look at this is, what do we have to know in order to realize something like this? How do we make this in sound? How do we create a sound event that's informed by this? Okay, so here's the song. We're going to get into the problems of this song as we go on. But I'll just give you a quick preview here. Here's the teaser. This song is generally considered to be in A flat. There's the last chord, the one chord. That's the tonic, home area. But if we look at the phrases, and this is divided into generally 8, 8, 8, and then 12 phrases, the ends of the phrases, the cadence, which is what usually defines the phrase, are not in A flat. So here you have a set of chords that's arguably in A flat, and then a change at the end of a phrase. And when I'm saying, again, this is the practical issue, it's the end of a musical phrase and it's the end of a lyrical phrase. In this song, this A flat is nowhere near a cadence. This is not a cadence. So the question becomes, if we're in A flat, why is that here in the middle of the phrase? And then something similar happens over here. Arguably, we can call this a sequence, and we have the same issue. Is it in E flat or is it in G? Because the end of the phrase is in G. Okay, so then we move on, and I'll talk a little bit more about this later. And then it goes to some really distant area in the circle of fifths, E. So you're in this flat area, and then arguably you're reaching, and then you get to E, and then whack, change. That's one of those curves on the ski slope, and boom, you're back in another tonal area that now looks very similar to this, except now it stays in A flat. So finally, at the end of the song, we can say, okay, now we're heading to a cadence, and there it is. Okay? So that's the harmonic problem of this song. So let's see, the next little thing, oh good, oh, it's there. I'm just gonna click and I'm sure we'll hear something. I hope we hear something. Why does that happen? Hold on a second. Yeah, it's here, just for some reason. So this is a little bit of Charlie Parker and Miles Davis playing this, and we're going to hear it from the very beginning of the recording, which is an intro that they added, and I'm keeping it for a reason. It's not because I couldn't cut it. So let's see now if I can actually hear it. Is it on? It's okay. So here's the melody. So what we're hearing there, oh no, play again, right? Yeah. No, it doesn't. Okay, so what we're hearing there is Charlie Parker, who's recognized as one of the masters, especially that style it's called bebop, and what we hear is, he's really helpful here, because what we hear is the melody, for sure, that da-dee-da-da-da, except he's filling in a lot of blanks. And the question is, how do you fill in those blanks? I mean, because that becomes his style, he's known for that, the genre is that. And the question, and I'm trying to always bring this back to the pedagogical applications, is how do you teach that? You know, how do you get somebody to do something similar, not a copy, but certainly how do you teach that process, because it's a process that's being used here. So, the general jazz approach, pedagogical approach, is to look at those little areas. This part is an A flat, and even the chords. Okay, so that chord is an F minor, and this is so you can play this scale on that chord, and then you can play this. So it's very fragmented. It's not that it's wrong, but it's vertical, and there's no warning sign about when that curve is about to come. And so what I'm looking at here, these are just two examples of people who talk about, okay, here's the analysis of all the things you are, here's the chord progression, and they say it starts in F minor, and then suddenly it modulates to C, but there's no real explanation about how it does that and why it does that. And my point here is, to move quickly through that, is that maybe if we understand this in something more of a long-range look, like Alan Fort suggested when he took the Schenkerian look and adapted it to popular music, maybe that can inform the realizations of these improvisations. And I'll just say that improvisation for me means not just the melodic improvisation, but everything that's going on, because then as we saw in that sheet, there's nothing there to tell anybody what really to play. And so the question is, can this longer range understanding help us out here? And I was actually, this is from Fort's book, and I see here that he too, in fact, he sees it like that it starts in A flat, and then it goes to C with a common chord here that he calls flat 2. That he calls flat 2. Here we go. And now he's in C suddenly, and then he's in another key. This is the sequence, E flat, and then it's suddenly in G. So this is also informing us that the relationship between the bass and the melody is generally thirds. And also I'll say here quickly that this third here, which is the F minor, is extended, projected into the next chord, so then it becomes this switch between 3, 7, 3, 7, 3, 7, the third and the seventh that happens in a circle of fifth motion. Okay, so this is his look on this. And then, very interestingly, he talks about how the voices move. And this, I think, is where we really have some great information, because I did a little analysis here of the voices in terms of the home key. I'm sorry I couldn't get the caret up here, but these are the degrees. And so what this whole song does, there's your F minor, there's your first chord, and there's your last chord, and what do we have here? Woo! 1 to 1. So this song, even though the harmony is very complex, melodically, this whole thing might be considered basically a move from 1 to 1 through the usual 6, 7, 8 or 7, 8. So here we go. So in terms of the key, we have a 1 and then a 7 and a 6 and a flat 6. It's descending, like these things usually do. And all the way through to where we get to that E major, which is the really crucial thing here, that I began to consider. So here, that's the E major, and then it's 1, and then it goes down again, and then the 4 goes to the 3 at the same time that the 5 goes 6, 7, 8, and we're home. Very tonal, very diatonic, extremely well structured, right? Melodically. Everything's perfect. So the question is, what's that E major doing there? So here are a couple of observations. The bass, if we look at just the fragmented key centers, what we find is this song is basically projecting in terms of the bass, is it projecting not a triad, as in Schenkerian thought. We're not in that world. We're in a world of 4-note chords. And that's something we have to deal with, I think, when we adapt this system. and question whether or not those extra notes are vertically consonant, or are they part of the chord, or are they melodic design chords, and what's the word? Notamological. Notes that will be taken away from the ultimate analysis and embellishments. Thank you. So here we go. The chord centers A flat C, E flat G, go up and form a A flat major 7 chord. Great. And then when you get up to that G, which is the leading tone of the home key, it stays there for a while. And then what happens? It comes back down. It doesn't go up to 8. Right? So it stays there in the middle of the song, and then it goes down to E through what could be its minor, E minor, it's relative, but it ends up to be a major. And then that major, with that great G sharp in there, that becomes 1 again, turns into, and here's the tag. To me, that turns into flat 6. And when it turns into flat 6, we go home. And then E, which was a destination point and seeming very distant, like how do we get here? Now we have a turn very simply and harmonically to go flat 6, 5, 1. And there we are. Before I play a little bit and show you what else I was thinking about here, I'm just going to point out one more thing that's really interesting about this song. It comes from the theater. And in the theater, generally, before the main part of the song occurred, there was what's called a verse. Because it's musical theater and there's some speaking, it's not opera, it's like operetta, you say things, and then the verse sort of bridges you into the song. What key is that verse in? G. That's interesting. So the whole introduction of this song is not in the home key. Where is it? It's on the leading tone. That's really something, I think, when we look at how this whole long-term structure happens. This composer is just sitting around proposing A flat that doesn't show up until the end. Right? And there's probably a lyrical connection to that as well. Okay, so this I'll skip through because I wanted to show you some of my applications of this that I've been working on. That will be in Sibelius. Where are you? Alright, I couldn't embed these things because I wanted to sound them. Let's see, here we go. Okay, so I won't play too many of these. My point here is, once we know this, how can we construct lines that are not the melody, but they're alternate lines that an improviser might use as those markers on the ski slope. Okay, I'm here, now I have to go there. It's not telling the improviser how to go anywhere, but what it does here is create a set of posts. And this is a simple one here. And so basically, this is a big deal here. And then I'll play a little bit on the alone. The point I'm trying to make here is that maybe what could be is that the song is not in A flat at the beginning. Maybe it starts on the flat 6 of the song. And if that's true, then A flat goes to G, goes to C is logical. A flat G, okay? And so when I'm playing, when I'm soloing, when anybody is soloing, they are not in A flat, as I learned it, but they are on A flat. A flat is an area of C. And then it sequences, okay, and now you're on E flat, and then you're in G. So you've made a move between actually G, the verse, to C, to G. And then so this game of in-on is very important, I think, when we get to look at this tune. I'll just flip by here because we're going to run out of time. The point I do here when I make these exercises is that I try to find lines that are interesting and logical and move from place to place. And they become alternate lines, not what we heard Charlie Parker do. What we heard him do in the first rodada, the first round, is use the melody. And then he played around with that. But as you go on, you can use other notes, like even the 9, for instance. And then you see where the 9 goes. And so my idea here, that's why I said I felt very linear, is that we're stacking possibilities of posts. And the complexity of the song becomes part of the game, but each chord has a place to go and a place to be. So now, because I'm going to run out of time, I'll play a little bit. Okay. Thanks. And I hope that was interesting. I'm having a blast analyzing this tune. And I think, again, in terms of how this look can be applied to popular music, pedagogy, theory, and planning of performance is really what I'm talking about here, how this is possible. So, take this down here. Okay, so this one starts with 9. See that? So basically, you have the, instead of about the intro. Give me 3 seconds. So the intro that Charlie Parker used was what? Flat 6, 5, 1. Right? Dee-da-do, 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 dee-da-do. So somehow they either heard that intuitively or really figured it out. Wait, this is what's important here, which goes to what? Informed performance practice. That's what we're talking about.
Now the third guest is Gabriel. He's professor at the music department of Rio Grande do Sul Federal University, and he's doctorate in musical composition with thesis from the pitch to the rhythm, so theory of rhythm sets as a compositional tool. He acts regularly in the instrumental scene, jazz and popular music. In 2019, he shared the stage with the French singer Camille Berthaud at the Jazz District Festival. In 2007, participated 1913. He published the book Combinatorial Harmony, Concepts and Techniques for Composing and Improvising by Mill Bay Publications. Among his awards are the first prize in the 8th IPEL Composition Competition, Big Band Edition, in 2006, and the first prize in the RS Instrumental Music Festival in 1996. In 2009, he selected for the performance, who was selected for the performance at the Sala Funarte Sidney Miller with his solo guitar work. He played with several national and international names, such as George Dick, Phil DeGree, the Greek Kiko Freitas, Fábio Torres, Cliff Corman, Edu Ribeiro, André Vasconcelos, Tony Horta, Eduardo Neves, among many others. With you, Juliana. Thank you for coming.
Bom dia, pessoal. Eu vou falar em português, mas eu gostaria de dizer que eu estou imensamente feliz de estar aqui. Realmente é uma honra muito grande estar nesse lugar, enfim, esse congresso de altíssimo nível, assim, com esses colegas fantásticos também. Tendo aqui o Robert Morris in front of mine. Thank you. Realmente é uma honra muito grande. Eu vou correr bastante aqui para poder falar as coisas que eu gostaria de falar. Então, música popular em teoria dos conjuntos rítmicos, uma visão panorâmica. Alguns slides estão com tradução em inglês para ajudar um pouco também. Então, from a panoramic view, the basis of the rhythmic set theory will be present according to the author's formulation, with emphasis on its relationship with popular music. Some topics to be discussed: isomorphic relationship between pitches and rhythms, dancing timelines and diatonism, rhythmic related complexities like rotations, divisions, illusions, and the novel concept of rhythmic chord symbols. From pitches to rhythm. A system of rhythmic organization parallel to the musical set theory pitch class organization, as well as an adaptation of the time point system. From the standpoint of the traditional set theory and also from the diatonic set theory, this unified approach allows to establish a connecting tissue of basic aspects from the harmony and chord symbols to the rhythmic organization. At one time, in a complete catalog, the families of pitch class sets and chord symbols are related to their respective rhythmic counterparts. The musical motivation for this research came from my interest in the swinging and groovy repetitive rhythms called timelines, commonly used in popular music. These dancing timelines have properties similar to those of the diatonic sets. Então, na verdade, a minha abordagem é uma coisa, de uma certa forma, muito simples. É simplesmente a gente aproveitar as propriedades das alturas como durações. E esses diagramas foram feitos, eles vêm da tese do professor Paulo X. Gentil Nunes. Eles são muito interessantes para elucidar os pitch spaces do professor Morris. Então eles são bastante intuitivos. Eu quero começar com isso porque os sistemas musicais ocidentais eles são baseados nessa discretização do contínuo das frequências. Então, esses espaços de alturas do professor Morris, a gente tem o C-Space, que é a abstração pura do contorno de alturas. Inclusive, ele falou ontem sobre isso, independentemente do valor específico de cada contorno. Então, ele é liso, ele pode modular em qualquer altura intermediária sem especificar a quantização ou grade entre os intervalos. Por outro lado, a gente tem P-Space, que ele é estriado, tem divisões regulares. Um exemplo instanciado disso poderia ser a escala cromática. U-Space, ele é estriado, tem divisões irregulares, mas periódicas. Então a gente teria como exemplo disso aí as teclas brancas do piano. Então a gente tem um espaço que é liso e dois espaços que são estriados. Outra forma de representar esses espaços é de forma cíclica. O pitch black space, que ele é estriado, tem divisões regulares, mas ele assume a equivalência de oitavas, né? Então a gente abstrai o registro em que se encontram esses. Então a gente tem o módulo 12, no caso de 12 notas, e por outro lado a gente tem esse M-space, que ele é estriado, ele é cíclico, mas ele é irregular. Então a gente poderia conceber as alturas diatônicas a partir desse diagrama também. Muito legal, foi muito inspirador ver esses diagramas do Pauchy. Bom, então quando a gente começa a organizar essas alturas e a gente representa ciclicamente, a gente chega nesses diagramas que eles têm módulo 12, então a gente tem uma congruência enfim, desses 12 sons. Eu acho que 12 é um número bom, embora o Toussaint, ele diz que as timelines mais comuns em música popular são 16, são de tamanho 16. Mas para trabalhar com 16 a gente começa a ter muitas combinações, então eu resolvi manter o esquema em 12, até porque eu poderia aproveitar todo o referencial que já existia antes, né? Então, e daí a gente já tem como trabalhar de forma mais prática com isso. Então, quando a gente faz essa discretização e passa isso para o tempo, a gente tem um grid periódico, né? E a gente usa também sequencers, né? Quando a gente está usando o computador, a gente vê esses grids são muito populares hoje em dia nos programas de computador. Representação do ritmo. A gente pode ter vários tipos de representação equivalentes dos ritmos, os necklaces, os relógios rítmicos. Então a gente pode representar esse tresílio de várias formas, né? 3 mais 2, pode representar de forma binária, pode representar, time box unit, várias representações diferentes. O que é interessante notar é que os ritmos que pertencem a uma mesma forma prima, eles são equivalentes por rotação. Então, por exemplo, a forma prima do conjunto 7/35, escala diatônica, é 0, 1, 3, 5, 6, 8A. Mas a gente costuma entender esse ritmo como sendo bang, né? Enfim, vou falar mais disso mais adiante. Então, a ideia de transformar alturas em pontos de ataque, né, vem do Babbitt, né, que ele fez esse esquema de time point system, ou seja, cada altura está relacionada a um ponto no tempo, né? Então a gente tem essa relação entre a escala cromática e os 12 pontos de ataque, 12 notas, 12 pontos de ataque. Essa é a forma que o Babbitt expressou isso, né? O engendramento de um sistema quantitativo temporal através da interpretação dos números de alturas como valores temporais, considerando que números ordenados são eles mesmos valores ordinais temporais na construção de um sistema rítmico dodecafônico, pode ser visto tanto como uma reinterpretação dos números de alturas de forma a garantir isomorfismo entre os dois sistemas, quanto a distribuição de interpretações temporais aos termos não interpretados das diferentes estruturas numéricas finitas semelhantes, das quais ambos os sistemas rítmico e de altura são exemplificações. Essa é uma forma bastante Yoda, é uma forma bastante difícil de dizer isso aí, mas é a forma como o Babbitt construiu esse conceito. Então, a minha ideia é bastante simples. Eu tenho aqui as alturas na forma de um acorde, e aqui eu transformo elas em ritmo. Então, eu projeto as distâncias, né, que eu tenho, que são harmônicas, eu projeto elas do ponto de vista rítmico. Então, isso aqui é uma tríade de Dó maior, ritmicamente falando. Então, aspectos isomórficos entre ritmos e alturas. Tem 12 classes de alturas, 12 classes de pontos de ataque, 6 classes de intervalos, 6 classes de intervalos entre ataques. Tricordes e nonacordes que são complementares se transformam em triataques ou nonataques complementares. Tetracordes ou octacordes complementares se transformam em tetrataques, octataques complementares, etc. Então, existe uma relação bem próxima. O vetor intervalar que o Forte criou também se aplica ritmicamente, porque eu posso ter as classes de intervalos entre ataques. também da mesma forma. Então eu posso analisar isso aqui tanto do ponto de vista acordal como do ponto de vista rítmico, usando os vetores do forte. Então, existem duas formas de usar o Time Point System. Essa aqui é a forma do Babbitt. A série é convertida em pontos de tempo que atravessa mais do que 12 pontos, né? Ou seja, a série se transforma em uma linha rítmica que é relativamente longa, né? Esse é o jeito que o Babbitt usa o sistema. Ou seja, a ordem é relevante nesse caso. 047 vai produzir esse ritmo, 074 vai produzir esse ritmo, 407 vai produzir esse ritmo, 470 vai produzir esse ritmo. Quer dizer, a ordem altera, a ordem do conjunto altera o resultado rítmico para o Babbitt. No meu caso, eu não faço isso. Cada conjunto de classes de pontos de altura é circunscrita dentro do módulo 12. A ordem não importa na formalização, na racionalização da forma prima. Cada ritmo é entendido como um acorde designando os pontos de ataque correspondentes às suas classes de alturas. Os ritmos longos, que a gente, no caso, para criar ritmos mais longos, a gente precisa fazer justaposição ou intersecção desses conjuntos de classes de pontos de ataque. Então, e o aspecto modular e cíclico, ele favorece a construção de ritmos circulares, né, como ritmos repetitivos, ritmos dançantes, né, como se usa em música popular bastante, mas não apenas, né. Então, para mim, tanto faz se é 047 ou 407 ou 740, vai gerar sempre a mesma, the same rhythm. The order is not important. Todas as formas primas no catálogo ficam dentro do esquema de 12 pontos de ataque, né? Algumas transformações são obtidas por operações similares àquelas aplicadas às classes de alturas, né? Por exemplo, transposição vai equivaler à rotação. Eu também uso os voicings, né, que a gente usa em música popular bastante, né, drop 2, drop 3, eu transformo eles também em ritmos. Então, a partir disso a gente pode conceber uma cifragem rítmica, ou seja, eu posso transformar uma cifra de acorde, que é Dó, Mi, Sol sustenido, ou Dó, Mi, Sol, Si bemol, Dó 7, posso converter isso num ritmo. Isso é interessante porque enfim, na música popular a gente está acostumado a fazer isso. A gente vê uma cifra e a gente imagina no piano ou na guitarra vários voicings para resolver esse problema. Por que não fazer a mesma coisa com o ritmo? Por que eu não posso usar isso aqui como um dispositivo mnemônico, né, para guardar certas ideias? Então eu começo a pensar que Dó 7 pode ser tá, 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 etc. Então eu posso começar a me referenciar, assim como eu começo a me referenciar a partir de cifras, eu consigo ter uma relação com o piano, com a guitarra. Da mesma forma, enfim, se eu começo a converter acordes em ritmos, eu começo a ter uma referência também de que estou usando esse ou aquele ritmo, certo? As rotações, como funciona? Se eu tenho Dó, Mi, Sol, eu faço a rotação dessa tríade meio tom acima, eu passo a ter Ré bemol, Fá, Lá bemol. Então, tá, 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 vira tá, 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 e assim por diante. Todas essas transposições pertencem à mesma classe, à mesma beat class. Então aqui eu tenho um exemplo, eu no caso construí esse exemplo aqui, que são dois conjuntos complementares, que é a escala diatônica e a escala pentatônica, que são conjuntos complementares, e eu vou mostrar para vocês como funcionam essas rotações. São rotações do mesmo ritmo, que, então, como o conjunto ali é a escala maior, a gente acaba tendo os modos também sendo representados dessa forma. Quando eu tenho rotações limitadas, no caso conjuntos de modos de transposição limitadas, isso também se reflete nas rotações limitadas em termos de ritmo. Então, o acorde de sexta francesa ele vai ter apenas 6 rotações diferentes, então, já que a rotação 3 é igual à rotação 9, a rotação 4 é igual à rotação 10, etc. Esse aqui é um conceito criado pelo Willy Anko, que é um africano, para conseguir mostrar as diferenças culturais que existem entre os ritmos. Muitas vezes a gente vai conversar com os músicos, por exemplo, na Argentina e no Rio Grande do Sul tem muitos ritmos parecidos, mas nem sempre as pessoas conceitualizam da mesma forma esses ritmos. Às vezes a gente pergunta para alguém, onde tu acha que é o downbeat desse ritmo? E aí, enfim, uma pessoa responde uma coisa, outra pessoa responde outra, porque elas têm a experiência diferente. Então, em relação a isso, dependendo da região da África onde você está, você pode entender a mesma forma-prima, o mesmo conjunto de formas diferentes. Então, ele inventou uma coisa que chama time point regulador, o Willy Anko. Aqui tem um exemplo para a gente entender.
Yoruba. TeMA.
Então, todos esses ritmos são de fato a mesma forma-prima, Então, no meu trabalho eu resolvi inventar uma coisa que chama Rhythmic Root, ou fundamental rítmica, ou tônica rítmica. Cada conjunto do catálogo tem uma nota específica que vai ser considerada a nota, enfim, referência para as rotações. Então, por exemplo, no caso do Dó maior, o Dó vai ser a rotação 0 e a rotação 1 vai ser a partir desse Dó. Enfim, uma forma de desambiguar algumas confusões que acontecem. Aqui a música do Stevie Ray, Clapping Music, consiste exatamente na rotação de um octataque 826. Então, o processo da música é exatamente esse. Aqui, a ideia de voicings rítmicos, que eu estou pegando um acorde de Dó com sétima maior e estou projetando as distâncias entre as notas como ritmos, né? Ou seja, drop 2, drop 3, projetados como intervalos entre ataques. Mais uma ideia de converter acordes em ritmos. Falando um pouquinho mais sobre essa ideia de isomorfismo, a gente vê que o bembe é um ritmo diatônico. Então o diatonismo volta a ter uma importância muito grande. A partir dos anos 80, vários autores começaram a pesquisar a diatonic set theory. E também eu queria falar sobre essa ideia de timeline, que o timeline é mais do que um ostinato, é uma coisa que é importante para a música no sentido de orientar os performers, né? Então, quando a gente faz uma música baseada numa clave qualquer, como som clave ou samba, isso vai influenciar a forma como a gente compõe e também como improvisa sobre essa música. Então, a partir dessa ideia de propriedades diatônicas, a gente começa a perceber que esse diatonismo passa a ser realmente importante. Eu vou pular essa parte porque não vai dar tempo, uma composição minha. Então, a partir dos anos 80, Clough, Dot, Meyerson e Johnson começam a pesquisar a teoria diatônica de conjuntos, né? E também, por exemplo, mesmo em Ligeti, a gente pode entender o estudo número 2. Eu fiz essa análise pensando em nuvens diatônicas, né? Porque o beaming das notas sugere que ele estava pensando em conjuntos diatônicos, embora não pareça ser isso. Quando a gente começa a pensar dessa forma, a gente volta a dar uma nova luz para essa coisa diatônica. Então a gente tem a teoria dos conjuntos musicais e um subconjunto dela é a teoria dos conjuntos diatônicos. Depois a gente poderia conceber uma ideia de teoria dos conjuntos rítmicos e como um subconjunto dela a teoria dos conjuntos rítmicos diatônicos, que vai tratar de algumas características especiais desses ritmos. Por exemplo, uma das propriedades diatônicas que interessa para a gente é a ideia dos conjuntos maximamente distribuídos, né? Ou seja, que se eu distribuo o meu conjunto de forma muito concentrada no lugar, eu não consigo ter um som dançante, né? Então eu vou dar um exemplo aqui. Por exemplo, acho que esse exemplo vai valer mais do que as palavras. Por exemplo, aqui tem meramente 5 ataques, aqui tem ataques distribuídos. Dançante. Não dançante. Groovy. Non groovy. Então, quando eu distribuo esses eventos no tempo, eu consigo perceber propriedades de por que esses ritmos são dançantes. Então, por exemplo, quanto mais alto o número de forte, mais distribuído no tempo é o ritmo, né? Então, por exemplo, aqui o 3.1, o 3.1, são 3 ataques juntos, e por outro lado o 3.12 são 3 ataques perfeitamente distribuídos no tempo, o que também não swinga. Se eu faço algo muito perfeito, também eu acabo não tendo a coisa dançante. Eu preciso de um pouquinho de irregularidade. Aqui são essa tabela do John Damian é muito interessante porque mostra as famílias diatônicas, né? Tríades, acordes quartais, sétima sem a quinta, sétima sem a terça e os clusters. Isso é uma boa forma de organizar os acordes diatônicos e foi a forma que eu usei no meu livro, Combinatorial Harmony, e me ajudou muito a organizar esse material. Usei também as partições do professor Morris, as classes de partições para poder usar, para poder organizar as subdivisões, né? Ou seja, os 12 pontos de ataque eu não preciso usar com a mesma figura, eu posso usar tadigenado taki tataka taka tadigenado taki tataka taka. Eu posso separar esses 12 pontos de ataque em figuras diferentes, então eu gero outros ritmos também. Então, por exemplo, se eu pegar o mesmo bembe que eu tenho mostrado para vocês e fazer desse jeito, eu vou ter... É o mesmo bembe, só que com outras subdivisões, né? Cria um outro tipo de quantize que está sendo bem usado agora. O Jacob Collier faz várias músicas com quintinas, assim, que é bem interessante de olhar isso aí. O catálogo que eu fiz na tese, na minha tese, ela usou o sistema de organização do Carter, ou seja, 4 grupos, né? Autocomplementares por rotação, depois o grupo B autocomplementar por inversão, grupo C Z relacionados não invertíveis e grupo D Z relacionados invertíveis. A forma que o Carter usou eu achei interessante para organizar o material. Ok. Só queria mostrar uma última coisa, que é um solo de um guitarrista que eu gosto muito, o Andy Krantz, e vocês vão ver o vídeo de como a gente pode usar os conjuntos rítmicos para tirar o material para improvisar e para... É muito interessante.
Good morning. My name is Aragão, and I wish I wish to thank you very much, Prof. Cliff, Prof. Júlio, Prof. Thank you very much. I had a question. Eu tenho uma questão para o professor Gabriel Pareyon. Do you remember the kind of principle of rationality when we use heavy math tools and you give us a principle about the mathematical difficulty and the disability.
Tirar a mão do microfone.
Do you remember?
Preciso tirar a mão da cabeça do microfone. Isso, aí pode colocar perto
The
do
principle about math complexity of math tools and disability. So now I ask you help. Can you imagine a kind of twin principle, another principle, sister, brother of your a kind of replicate of your principle, but when we use the simplest math tool we can. Do you understand? Can you help me with this? So we have a proportion, the easiest math tool, what we can put in the second part of the fraction, in the denominator. I ask this because my principle of work is to look for the easiest math way to explain the musical things. Musical ideas. So what can I do?
Well, thank you for your question. First of all, I must say that I enjoyed very much second and third talks. And yesterday as well, there were some lectures about musical simplicity and complexity, but the concept symmetry is not very mentioned in this Congress. I think it's quite important. And in both lectures, second and third, from my colleagues, we musically feel quite clear this length from simple symmetry and almost simple symmetry and deviations. So most of music, in harmonic and metrical and melodic and other components are related to this approach to radial symmetry, inversion, retrogradation, and inversion retrograde. I will say much more than that. It's a very classical principle for music, poetry, dance, and so on. And the second lecture, sorry, but you promised not talking about non-linearity. It's a good joke, actually, because you stress very much linearity and symmetry, but what we hear musically is interesting deviation from this. And this is part of what music and musicology is most difficult to express in words. It's rather the feeling of deviating from this symmetry. And as Professor Arthur Campbell yesterday, he brought some examples of regularity and the deviations from this symmetry. In my own model in TeMA with these necessary non-straight lines, we cannot rationally define how deviated are those lines, but musically it's rather intuitive. I don't know if I'm answering my question.
Any other question?
First of all, I enjoyed all these few talks. I think they were really terrific. And
which are also based on symmetries within jazz. And so there's really a tremendous repertoire of interest in your analysis of it. And also your demonstration is great too. Now about the first talk, I'm very open to the idea that we can use many methods from rather advanced mathematics, etc., to maybe make postulations about what might happen in human forms of expression, etc. They're there. That doesn't mean there's a necessary combination. I mean, there is a philosophy of mathematics which is called Platonism, in which you think that mathematical objects actually exist, and they're there to be discovered. You don't construct the mathematics to discover it. Another form of mathematics would be in which you construct mathematics. In which you construct abstract systems which somehow have correspondences to the world. The problem with that point of view is that how do you justify the fact that there could be any correspondences between these abstract structures in the world? So when you find many of them, you're forced back to think about maybe the Platonic position is the right one. So there's a big conflict in the philosophy of mathematics about this very issue. And the reason I bring it up is because if you want to say, okay, the distribution of primes has something to do with the way we construct scales, that's interesting, but it's not a necessary combination between that. It's just something you can take and use if you wish to. And of course, it gives you insight too into how scales are constructed. I don't have any doubt of that. But the real problem I'm having, and I said it, you mentioned it before, is the quick to jump to universals before we examine the cases carefully. Musics are not the same all over the world. They have lots of differences. There are some musics where there aren't any octaves, or there's some music where there aren't even fixed pitches. Every instrument is tuned differently, like a gamelan. And there are other instruments which, of course, music where metrics are taught completely, as in Almada and American classical music or in Musicological playing. So there's almost everything that you think that would be normal or whatever culture you're coming from will find probably another place in the world where it doesn't happen. So there's a kind of fuzzy connection between things, but it's not something you can really hang your hat on. So that's the thing I worry about, because the idea of universality gets you into a position where you start thinking that your way of thinking is the way it should be, and then we get, of course, pulled into all the problems we're having now in our country about diversity, etc. So that's where it's coming from.
I just like to summarize somehow this with the relationship between universalisms and diversity. It's a necessary relationship for musicians, for musical culture, and of course a relationship between cultural certainty and necessary uncertainty as a necessary ingredient for creativity. With music, in every culture we need to create, and that's we need uncertainty. That's why your performance was not full of certainty, absolutely, but I enjoy very much your hesitations in your demonstration. That's musical, absolutely.
I don't know what creativity means. In fact, when you try to find creativity, you can't really, because if you have a definition, you'll be able to create it without having creativity. So there's a kind of an anomaly there that I don't understand. But some musics are produced, are totally functional. They are not interested in creative behavior. They're interested in just doing it correctly. A lot of, for instance, ancient rituals, etc. You play, it's music, but you play it in such a way that you don't add anything to it. It's already there in some form. You perform it. Other musics like jazz has definition of creativity built into the whole fabric of it. So there's a continuum of how much variation, we might say, over performance will occur. And whether the variation is based on imagination is another question. So I keep all those things in mind. But in general, I agree that music does connect with people, and it does have something to do with phenomena that are in the world, and also when you can describe the world. It's just that I can't make the connection clearly in any particular case. I'm familiar with particular cases, but I can't make it general.
Nothing to add, because I fully agree with you.
Okay, fine.
Questions?
linearidade, e eu fiquei um pouco preocupado porque muitas coisas que aparecem aí, aparece um fenômeno chamado emergência. Como você bem disse, as partes de um sistema não descrevem todas as propriedades do sistema. Mas não linearidade não necessariamente está ligado com emergência. Por exemplo, se você pega um pêndulo, ele faz um movimento regular. Se você pegar um duplo pêndulo, ele fica caótico. Aí você já tem caoticidade e complexidade do conjunto, do movimento do duplo pêndulo, e você tem bastante complexidade. Mas não existe, ninguém fica falando de emergência do duplo pêndulo. Quer dizer, a complexidade são duas coisas que podem ser aplicadas em diferentes conjuntos. Então, eu não vi na sua apresentação como é que você usa a não linearidade dentro da sua proposta. Porque eu percebi mais emergência do que não linearidade do ponto de vista matemático. Então, assim, se você puder explicar onde você usa realmente que f de x mais y é diferente de fx mais fy.
Muito obrigado. Porque os presidentes falam inglês, mas não português. So I will answer in English. If I'm not wrong, Pythagorean, case called piece of Thematic, where Thematic used differential equation for the representation of gas behavior in order to create a metaphor. It's a rather metaphorical use. In this translation of mathematical language into musical one, he uses quite often, metaphors, not analogies. An analogy is the use of proportionality to create something. But indeed, the final result in Pythagorean is quite non-linear, because the behavior of a single part of this complexity is relatively independent.
Yeah, that's the problem I have. You are using complexity and non-linearity. That's a kind of synonym.
No, could be synonym. Not necessarily. No. I'm not involving necessarily complexity into non-linearity. And as well, we have like the Euler function I presented. We have phenomena like linear phenomena. Intuitively, we feel and we represent and we see mathematically they are linear and almost linear and almost non-linear, like the Euler's function, and completely non-linear. So we have shades, gradients of these kind of behaviors, and complexity may involve this complex emergency, including emergent patterns like self-similar patterns and self-dissimilar patterns, which are very counterintuitive. How a phenomenon can exist, a dynamical phenomenon where local behavior is completely different to the rest of the system. So we have gradients and shades. In music is quite representative.
It showed non-linearity. For me, it didn't show non-linearity, it showed non-isomorphism, which maybe is the same thing, but that would be
Isomorphism is linear.
Well, isomorphism is linear, of course, but I'm saying that non-isomorphism doesn't mean that anything is actually one way or the other. It's just saying that you can't map this to that and keep the structure. Right? Okay. So in that way, it seems to me that when you were talking about what you were saying, there might be a mix-up between chaos and non-linearity. But I wanted to say about Pythagorean, what's going on there is he has some equations, and if you throw in a number you expect in the equation, you get an answer you expect. What he does is throws random numbers into that, and then they give you different possibilities. And he calls this stochastic because what's going to happen is that there are deviations from some sort of norm that would be the norm of the random numbers. And consequently, that's going to produce certain kinds of outcomes. Any of them alone is independent, but as a group, because of the equation for these sort of things, and there's going to be some sort of regularities. So it is non-linear, but it isn't chaotic.
I don't know if I have something to add to complete my answer.
When you use even linear systems, but you use a massive system, you get a lot of complexity. That's linear.
Yes. It's not necessarily correlated.
So, for example, see if you ligate 100 what? No.
Yes.
Everything is just a tick, but different
Results.
So for you, when you receive that massive information, it's chaotic. Everyone is linear.
Yes. For example, quantum mechanics is linear.
Mechanics is linear, but
It's complex and linear.
sorry.
Very good. I'm very.
If you could listen to all the methodologies examples, you would see the context.
Yes. You did one.
I'm very sorry, but we have no slide more. And we make a brief pause, no? 5 minutes.
Go now.
And we will go to the 18th floor for the communications. There are two rooms.